Everyone. I hope you're hanging in there. We're going to get through this together. We're going to do some online learning now, and the best thing I thought to start with is imaginary numbers. Imaginary numbers is not easy to wrap your head around, but the process and what I'm asking you to do with imaginary numbers is very easy. So I thought after doing our radical unit that this would be the best thing to do instead of switching gears to completely something different. And this you're going to be able to get through pretty easily. So, what is an imaginary number? An imaginary number is a complex number introduced to make it possible to solve equations without any real solution. What does that mean? If we look at this example, x squared equals -1, there is no solution to that. There is nothing I can put in for x that is going to result into a negative number. It's impossible. And that's where imaginary comes in. Some mathematician defined I as the square root of -1. So now, anytime I have a radical that's basically impossible to solve, I can pull out a -1, and then it allows me to solve the radical or simplify the radical. What you have to memorize, though, is anytime we get I squared, so for example, you get an I times an I, that is going to result in -1. And you're going to have to memorize that as we go along. So the next slide is where we're going to practice that at first, and then you'll see where the definition of I equaling -1 comes into play. Okay. We look at the powers of i's. This should make sense to you. I to the 0 is 1. Well, anything in the world to the power of 0 is 1. 4 to the power of 0 is 1. So we know I to the power of 0 is 1. I to the power of 1 is going to be I. I squared is something you just have to memorize. So now I know if I have I squared is -1. If I had 3 i's, 1, 2, 3, this would become -1 times I would be -I. So right here, that's y to the third is -I. If I have 4 of them, I times I times I times I, this is going to be -1. This is going to be -1. Well, -1 times -1 is 1. So this is also going to be really important. Sorry, this pen is not really sticking to this. This is also going to be really important because any number I give you, if you can get it into a multiple of 4, it's obviously going to be a 1. So an example of that, if I have I to the 18th power, okay, I know that I to the 16th, right? Sorry, this pen is not really working. I to the 16th, that's 4 sets of 4, is going to be 1. Then I'm going to have an I and an I, because if we were going to 18, that's 2 left over. Well, I times I is I squared, and I squared is -1. So 1 times -1 is -1. So I to the 18th is -1. Okay, let's look at another one. I to the 33rd, 3, 3. Okay, well, what can I get sets of 4? So 4 goes into 33 how many times? So if we think about it, it goes into it 32 times evenly, so that's 8. So I to the 32 sorry, I don't know what's going on. Change screen so it'll help. So I to the 33rd, we know I to the 32 would be 1 because sets of 4 always equals 1, and there's 8 sets in here. But so how many would I have left over? 1i, and 1 times I is I. So I to the 33rd is 1. All right, so that's the concept of I squared and the powers of I. And we should be good at that. Not the most important thing we need to do with I. So let's look at what we do need to do with I. I look at these three examples: square root of -5, square root of -25, and the square root of 50. You cannot take the square root of any negative number. Remember, we could take the cube root of a negative number, but we cannot take a square root of any negative number because you're asking yourself what number twice gives you that. What I can do is, by definition, take out a -1 and then this. When I take out the -1, that is the definition of I. So my answer here is just I square root of 5. So it's an imaginary answer and giving me the square root of 5. Here, I would take out square root of -1 and 25. So now this is I square root of 25, but the square root of 25 is 5, so it's 5I. Or I5, doesn't matter which order you write it in. 50, if you're picking up on, you're allowed to make this I the square root of 50, meaning that you really can't do this problem. But if I use imaginary numbers, it will allow me to do this. Then I break down 50, 5 and 2. I have a pair of 5, so 5 gets to come out with the I, and the 2 goes inside. Before going on, why don't you try the square root of -48? And let me know what you get as an answer. So first thing I would do is take out the I square root of 48, and now you need to break down 48. So we could do 8 and 6, 4 and 2, 3 and 2, 2 and 2. Pair of 2s, pair of 2s. 3 has nobody, so it's 4I square root of 3. Okay? So once you get the concept that I equals -1, we really should be able to do any operation of radicals with imaginary numbers. Now, the thing you want to be careful about, this is not, you cannot do. This is a real number. So we can't put these together because this is not real and this is real. So what I can do is I square root of 16 minus, and if you want, the square root of 49, you should know is 7. If I take the I out, now I'm going to break down 16. I get 4 and 4. I can stop there. The square root of 16 is 4. I get 4I minus 7. I cannot put them together because, like we said at the start, this you cannot do. This is real. When I look at this one, this and this are not real. They're both going to be imaginary. So if I did I root 3 and I root 27, that would be fine. I could add these together if this and this were the same, because that's the rules of radicals. So I root 3 plus, I break this down, 9, 3, 3 and 3, pair of 3s. I root 3 plus 3I root 3. Now my radicals are the same, and 1 plus 3 is 4I root 3. So when they are both starting as not real numbers that we can take answers to, then we can do it all in the imaginary form. Before going on, why don't we try square root of -18 plus 2, the square root of -8. Square root of 8. 9 and 2, 3 and 3. I'm going to get 3I root 2. I'm going to get 4, 2, 2 and 2. I'm going to get 4I root 2. Together, 7I root 2. Okay, so that's the process of adding imaginaries together. All right. Last we have for today is multiplying and possibly division. So if we look at this, this is not a real number. This is not a real solution, I should say, that you would not be able to solve these. But if I pull out I and I pull out I, now I can multiply these together. But we have to be careful. So when I multiply I times I in front, I'm going to get I squared. And when you get I squared, it has to ring a bell. And when I get 4 times 25, I get 100. I squared is -1. That's what we have to remember. And the square root of 100, which then can break down to 10 and 10 pairs. So -1 times 10, this answers -10. Without imaginaries, we would not be allowed to do this, but with the definition of I being -1, the square root of -1, that's why we're allowed. So when I look at this, the i's already out. I squared root 6. I squared has to ring a bell. It is -1 square root of 6. Let's look at these next two examples before I give you another one. Okay. This is just simply multiplying with I, so 6I times 6I, that's what it means to square it. 6 times 6 is 36. I times I is I squared. Anytime we see I squared, we say 36 times -1, 30, -36. Let's look at this next one. I'm going to just write it twice. Sorry, 5I root 3. 5I root 3. I'm going to take each of these separately. 5 times 5 is 25. I times I is I squared. Square root of 3 times square root of 3 is 9. 25 I squared is going to turn to 1, -1, sorry, and that's a 9. So I'm going to get -25 times 3, and I'm going to get 75, -75. All right, if you wouldn't mind, could you try -4 times -10 and see what you get? So I root 4 and I root 10 because you're not allowed to solve them. So I squared root 40, that becomes -1 root 40, 10, 4, 5, 2, 2, 2, pair of 2's, -2 root 10. The last problem I'm going to do is 11. What we just remember is I really represents the square root of -1, which means if it's a radical, we cannot have i's in the denominator of a fraction, just like we can't have a radical in the denominator of a fraction. Well, we know I times I gives us -1. So if I multiply this by I, the bottom of this will become 2 times -1, which is -2. And that gets rid of the I. But in order to get rid of, if I multiply it on the bottom, I must multiply it on the top, which will give me I the square root of -7 over -2. But I can't leave a negative in a radical. So it would become I times I root 7 over -2. It would become I squared root 7 over -2, which becomes -1 root 7 over -2, which becomes root 7 over 2 because they will cancel each other out. This is a lot. I will do another video on just getting out of the denominator. We'll talk more practice about that. It's definitely the harder concept. What I would like you to be able to do is break down radicals that have negatives inside by using imaginary numbers because the definition of I is the square root of -1. All right, we will practice and most likely have a Zoom session together. Thanks, guys. Bye.